if A vector is a constant vector and R vector is the position vector, then so that the cross product of A vector with R vector is a solenoidal vector. Constant vector means the vector whose magnitude and direction do not change, that is called a constant vector. Suppose the constant vector A vector equal to I cap Ax plus j cap Ay plus k cap Az, and it is given R is the position vector, the vector which originates from the origin of the coordinate system is called the position vector. Suppose the R vector position vector is I cap x plus j cap y plus k cap z. Then what will be the cross product of A and R, A cross R? If you take the determinant of A vector with R vector, that is I cap, j cap, k cap, then Ax, Ay, Az, X, Y, Z. If you take the determinant of I cap, j cap, k cap, Ax, Ay, Az, X, Y, Z, then that will give you the cross product of A with R or A cross R, and the determinant will be equal to I cap, then Z Ay minus Y Az, Z Ay minus Y Az plus j cap into X Az minus Z Ax. So X Az minus Z Ax plus k cap Yax minus X Ay. So k cap Yax minus X Ay. This is the cross product of the constant vector with the position vector, and we have to show that the cross product of constant vector and position vector is a solenoidal vector. And we know for a solenoidal vector, the divergence of the vector is equal to 0. So if we can prove that divergence of A cross R is equal to 0, then A cross R is a solenoidal vector. Then to find out the divergence of A cross R, we know divergence can be represented by del operator, that is del dot the vector operator, that is called the divergence of the vector. So del dot A cross R, this must be equal to 0. For A cross R to be solenoidal, the del dot A cross R will be equal to 0. And what will be the del operator, as we have defined previously about the del operator, which is nothing but a vector operator and can be represented as I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, dotted with A cross R. A cross R, this vector, that is I cap z ay minus y az, the ith component, then j cap x az minus z ax, this is the jth component, and k cap y ax minus x ay, this is the kth component. And if you take the dot product of the del operator with this A cross R vector, then you see only you have I dot I, j dot j, and k dot k, which is equal to 1, and other dot products are equal to 0. So we will only take I dot I. But if you take the partial derivative with respect to x, then you see here there is no x component, so that will be equal to 0. Similarly, if you take partial derivative with respect to y, because only you have j component, j dot j equal to 1. So if you take partial derivative of this with respect to y, this will be also equal to 0, because here you have no y component. Similarly, if you take the partial derivative of this component, kth component, with respect to z, then that will be also equal to 0, because you see here also you have no z component. So the final value, that is the divergence of the vector, that is A cross R, is equal to 0. That is why A cross R is a solenoidal vector. So remember, if A vector is a constant vector and R vector is a position vector, then the cross product of A cross R will be solenoidal. Solenoidal.